Let's take a look at how motorized dampers work in an HVAC system. Motorized dampers can operate with voltages anywhere between 24 volts and 240 volts AC, and they work with both 50 Hz and 60 Hz power supply. Once power is supplied to the actuator, it automatically starts opening the damper blades. The actuator also comes with two built-in auxiliary relays. These relays send normally open and normally close signals to the BMS system. If you check the control diagram, you will notice the terminals labeled S1 to S6. The wiring connections can be identified by the color codes, and in this setup, S1 and S4 are the common terminals. When the spindle clamp is at position 1, the auxiliary relay sends a close signal, and when it moves to position 10, it sends an open signal. The actuator motor has a torque rating of 10 Newton meters. For larger dampers, they are usually supplied module by module and connected together with bolts. Each module can be as large as 900 mm by 1500 mm. The damper blades are designed to handle air velocities between 7 meters per second and 15 meters per second. If the velocity increases beyond this range, the blades experience higher forces, which can cause twisting or deformation. That is why it's not recommended to install dampers too close to a fan discharge, near abrupt duct transitions, or beside elbows without guide vanes. These areas create turbulence, and that can easily damage the blades over time. Now, for testing or maintenance, the dampers can also be operated manually when there is no power. To do this, use the manual override and turn the hand crank until reach the desired position. Then, turn the manual override anti-clockwise, and the damper blades will open through the shaft clamp. Once it reaches the position you want, lock the override. After completing the test, switch it back to the open position. Because of the return spring mechanism, the damper will automatically move back to its original closed position when power is off or power failure. This spring return feature is very useful. Even if there's a power failure while the damper is open, it will automatically return to the closed position, ensuring proper air control and safety in the system. To replace a faulty actuator on a damper, first loosen and remove the shaft clamp that connects it to the damper shaft. Once that's done, simply pull the actuator out from the shaft and install the new one in its place. After installing the new actuator, make sure to tighten the shaft clamp securely so there's no movement during operation. Finally, reconnect the control wiring and test the actuator to confirm the damper opens and closes smoothly.